Great. How's everyone doing today? Getting settled in? You've spent time with weird things on your head, blocking out reality. So I'm sure that this will be refreshing. So I'm really happy to be here along with Teradici and AWS ThinkBox to kind of walk you through how we kind of worked our way up to this place where the running a VFX workstation in the cloud is not only possible, but actually reality, something that people are using in real world and getting great results from it. For those of you who may or may not know who Sohonet are, so we've been around for about 22 years, started in Soho in London, really with just 5 VFX guys, post-production guys in a pub, trying to solve the problem of how do we move really big files around, and realizing that what had worked well in the kind of film and even analog tape world wasn't going to work in a digital world. And so as a result of those conversations, really they decided that what they needed was a network, and that Sohonet was born. And over the last 22 years, it's evolved into something that is ultimately everywhere where major media companies need us to be. And so it just gives you a sense of where we have our infrastructure and where we have our customers. So as we think about the problem of creating a private network, which is really all about keeping content off the internet, it's about controlling contention, latency, ensuring that people have the bandwidth that they need for projects, and of course that they have the support they need for the kinds of workflows that M&E needs. You know, those characteristics of that network were kind of boiled down. And so then as people look to move off of that network into the public cloud, it turns out that the characteristics of the private network made really good sense for direct connect as well. So, you know, fundamentally, if you remove the internet from the routes, you get better performance, better security, right? That scalability, the ability to kind of scale the speed of your connection up and down, to move it to different on-ramps, you know, to take advantage of both the geographic location of your teams, but also the locations of the services that you want to consume. That's really, really important. And so that flexibility is kind of at the heart of it. So then if you then kind of extrapolate from that, you start to realize, well, you could always go out and build your own direct connect, and you know that involves a lot of CapEx. It involves hiring expertise in to manage that connection. And of course, it's really all about figuring out how much you need, because typically if you're negotiating directly with a telco, you're not going to get the flexibility that lets you say, right, I need 100 megs when I'm not doing anything just to keep the connection alive and let me do a little bit of testing and setup. But when a project comes along and I need 10 gigs, or then I need to turn it down to 3, or then I need 40, right? That ability to scale up and down is just not built into the way telcos operate. So, you know, we like to just think of this as kind of a way to extend from our network to the public cloud with really kind of the simplest flow chart possible, which is, are you on SMN, which is Sohonet Media Network? Yes? Okay. Then you can have access to the cloud. So obviously our goal is to get to the on-ramp from the cloud provider that is closest to the POP and closest to where you're working. So we have connections all over the world. We're working with the AWS team and our customers to identify all those other on-ramps and places where we want to go. But obviously the places you can see, like Vancouver and LA and London, those are the places, and Sydney are the places where a lot of our customers are trying to access AWS. We focus really on getting as close as possible because, you know, that's how we control latency, and that's how we ensure the performance of the overall process. So just as a reminder, so why not do it over the internet? You know, fundamentally, the difference between the internet and a service like ours, a direct connect service, is about predictability. It's about the fact that, you know, you don't want to have to deal with the contention. You want the guaranteed bandwidth that you paid for, because everything that you do and how you assume your services need to scale is all about knowing how much bandwidth you're going to need. And as we talk through with the Teradici guys and with AWS, they're going to kind of give you some guidance in terms of, for every workstation instance you spin up, you should have this much bandwidth. Right? So that math doesn't work if your connection is not going to give you the advertised bandwidth that you would get. And then obviously, all of the things from the contention that might be there that can be severe, the cost for bursting up and down, and the security profile just means that a direct connect service like Fastlane is going to just serve you much better in the long run. So as we look at how people use the public cloud from our network, so in the M&E space, render is the use case that I think everybody knows well. There's certainly been a lot of use cases around that. We were happy to share some with you. But fundamentally, those success stories about the ability to scale up and use compute in the cloud, kind of well documented. But of course, that's not the only things that we know our customers are doing. They're using it for access to cloud storage. They're using it to access other services in the cloud, whether those are transcode, distribution, all kinds of elements like that. So it could be even corporate IT resources. But obviously the topic today is really about getting access to virtual machines that will let you have a virtual workstation in the cloud. So I'm not going to run through these use cases in any real detail, but obviously they are on our website. We're happy to discuss them with you in depth. We have a whole bunch of Sohonet folks that are here. So what I want to do is just spend a couple minutes talking about the specifics of the workstations from a direct connect standpoint. So latency is really an important element, and when Ian is talking about the zero client and what it demands in order to be able to use a tablet, for example, we know that keeping latency below 20 milliseconds is key. You'll recall from the slide before, there isn't a single AWS on-ramp we have has more latency than 12 milliseconds right now. So obviously maintaining that means that your artists don't have lag and they don't feel like a drunken sailor when they're trying to use the workstation. The bandwidth needs, so again, just that ability to scale up and down. I start with 100 workstations, then I need 200, then I need 400, then I'm going to go back to 100 as your project kind of ebbs and flows. Well, obviously you don't want to pay for what you're not using. Likewise, if your project is across multiple geographic centers and you have a team in Vancouver and you have a team in LA or you have a team in London and you want to be able to move around and take advantage of multiple on-ramps, you want to have that flexibility. And then obviously security audits are a thing. And for any of you working for the major studios, going through that security audit process, whether it's the Marvel Disney process, the Warner Brothers process, they're all a little bit different. And working with a partner who's been through it and knows how to document it and knows how to kind of help you move through that process, it's obviously going to save you time and money when it comes down to it, and could be the difference between getting the job and not getting the job. I'll just point out that there is about an hour-long workshop that we've filmed in Germany at the FMX show with Mike and Ian and a few other folks, along with a couple of our customers, talking in great depth about their experience doing virtual workstations. So I invite you to find that. You're welcome to email me and I'll send you a link to it. Just a reminder about the bursting and the profile of what your usage may look like. This kind of graph, it can be scary if you're trying to predict the needs that you have, but obviously for us, this is typical of a Fastlane profile. So maintaining that very low baseline at a very low cost, just keeping the signal open, and then being able to add bandwidth when you need it and reduce it back down without penalty is kind of the key that we like to focus on. And then just before I hand it off to Ian, our only real suggestion to you guys as you're thinking about this is to give it a try. The key that we found, every customer who's succeeded in using our public cloud services for real work have tried it first when the money didn't depend on it, when the job didn't depend on it. So talk to us. We're more than happy to work with you to set up a proof of concept, to let you do real work, but obviously in a test environment, we'll help you figure out how you're going to scale that. We're going to help you figure out how to document whatever network changes you've made or whatever security accommodations you've made so that you can pass an audit when it comes time. And obviously the other part is just to determine your scaling factors so that if you know this is how much I need to run one workstation or 10 or 100 or 500, then the math is pretty simple to then figure out, okay, when the project comes, it's going to cost me this. Right? So that's pretty much all we've got. I think the real detail will come as Ian and Mike walk you through their presentations. Obviously, we're here to answer questions, and we're getting through this for the Q&A section. So we're around. We have network architects here. We have all kinds of folks. We're more than happy to answer any specific questions you have. So with that, I'll hand it off to Ian.
So I'm Ian Main from Teradici, and just by show of hands, I'll look like this. Who does not familiar with Teradici and our technology? Quite a few? Okay, so we've got a mix of people. So Teradici started back in 2004 as a semiconductor company developing a very high-performance encoder and a decoder chip, which gave us this very high-performance remote desktop experience for workstations, and that was really well adopted by the media and entertainment industry because of its high performance and low artifacts and things compared to other protocols at the time. What many people may not realize is that over the years, we've evolved into an enterprise software company, and our relationship with AWS goes back to 2014, where the PCoIP protocol was integrated into the Amazon Workspaces. And more recently, we have a product called Cloud Access Software, which can be integrated onto a G3 instance, and you can go to the marketplace. And Mike will be speaking a bit more about the details of we have. So that's the company evolution. And the reason the protocol has been such a success in the M&E industry is different factors, but the performance of the protocol from a low artifacts, high frame rate, color accuracy perspective, you need to make sure that the artists are working on an accurate rendering of the image compared to what's on the host side. The security is important in this industry, and I'll talk a bit about that later on. And then you need an easy deployed solution, and it needs to support Windows and Linux, because VFX industry is heavily Linux-based. The video editorial industry's got a lot of Windows, so we need those different capabilities. Now, these days, there's lots of different ways of remoting a desktop. A lot of them using video codecs, and the problem is that they don't do color to the accuracy of the actual originally rendered image. They do various types of quantization, and so an artist will be left guessing, when they're drawing on a screen, is that the color that was actually rendered by the workstation? So PCoIP has a built-in technology called build to lossless. That means when an image is stable, it's actually the bit exact reproduction of what's originally been rendered on the workstation side. So we're moving to a pretty exciting phase now with the cloud vendors offering these really high-performance graphics machines for you to put your workloads on. And this ties really well for VFX and post-production, because the model is very much project-oriented. So you don't want to have these big CapEx expenses, means you've got to amortize it over a long period. If you're project-oriented, you can start getting all your computing on demand. So there's a great tie with this capability of on-demand computing compared to the traditional way of on-premises workstations. And hand in hand with that goes all sorts of benefits, like being able to get rid of those expensive downtown real estate of your data centers and let AWS take care of that side of it for you. As well as flexibility in having your artists deployed from different jurisdictions where they might be getting tax advantages, and moving your teams around as required without having to mess with your data center infrastructure. And you can do all that now, like maintaining the same performance and characteristics and security compliance as you have for your studio environment as it is today. So this is just a journey that we're seeing customers taking. Up in the top there is the traditional workstation under the desk. It's got a big security footprint. It's got big power consumption, so there's air conditioning issues. You've got IT maintenance. So we still have studios have mixes of those, and some customers are still using that, especially the smaller environments. But 7 or 8 years, for the reasons I talked about, many people moved to what we call the remote workstation card, which is plugging the graphics from your workstation, feeding it into our hardware encoder, and then sending that out using PCoIP. Now, more recently, we have the cloud access software, which is virtualizing. Instead of having that hardware encoder, there's a software encoder, and you can go look at it out on the show floor at demonstrations, which now gives us a path to supporting the media content of the future, 4K, HDR, and so on, because we're now moving into a software environment. And of course, we're now moving to this great public cloud capability where you can start with your on-premises, but the public cloud is there. And we've provided some tools I'll just touch on that support this transition. So it's pretty great. So this is a hybrid architecture of some on-premises. You're not going to get rid of your on-premises equipment until it's been amortized, but you can start building out some public cloud test infrastructure and then start deploying that on a sort of case-by-case basis. So we have workstation cards and the software I was talking about. And of course, you have this render farm, which is limited in size because that's expensive compute nodes. And many studios end up with a fairly intricate pipeline to make sure their graphics workstations are fed into the render farm at night so that they're utilized properly to the best, get the highest rendering performance. So it gets pretty complicated. If I look to the right there to the public cloud, not only do you have the highly scalable render, which is where AWS's strength comes in, you can front it now with a virtual workstation, which means you're not transmitting data on and off your facility. And that workstation can be independent of the render farm, so you can power that down when you don't need it, and you're not incurring costs unless you're actually using it. So you don't need to worry about the overall costs of your workstations other than when you're actually running them. And you'll see on the far right the Cloud Access Manager, which I'll speak about presently. So Cloud Access Manager is an addition to our products that we added earlier this year. And it's a software service managed by Teradici. And what that allows you to do is broker and provision virtual machines either in the cloud. And as of starting this August, we actually have a connector. That's in the on-premise environment, the little small box there. That's the ability to broker your machines on premises. So we have the ability now to broker your machines on premises, or you can extend your network out into the cloud and broker those too. And coming on our roadmap will be the ability to broker your old workstation cards through the same infrastructure. And at the moment, this is all single region. So you'll see that if you want to access cloud, you have to go through your on-premises environment through a security gateway. But what we'll be doing is making that cloud connector be deployed wherever you have your region, so that artists in any region can just access their local cloud, because for latency purposes, as Ken was mentioning, you want to make sure that you're really close to your nearest data center. So this is the architecture that we'll be building out, including the capability to broker connections directly to your nearest cloud. This is just a screenshot of the user interface for the Cloud Access Manager. Simple brokering mechanism. You have a bunch of users, you have machines, and you can connect them up, and then you can do configuration for your machines in addition to that. Now, I mentioned security as a key requirement, and another reason why the PCoIP protocol is so well adopted in this industry is that many of the major studios have their MPA compliance. They have their Marvell compliance, which is the big, thick book like this that some of you may know about. Because we're just sending encrypted pixels from that secure content network out to the data out of that air gap from historically your private cloud, but now you can put that into the public cloud. Make sure you have the secure air gap in that, and you can access in a compliant fashion your secure data network. What some don't know is that there's that small client box within the secure content zone. Is that we have a client, Windows and Linux clients that can be put in that secure content zone, which gives artists the ability to go out from there into the public internet in a back-to-front protocol way, so that they can go access assets and still maintain this integrity of that content zone. So that's just to keep the architecture compliant. Just wanted to finish off on a question that came up. Ken's already touched on, is performance. He talked about the latency side of it, but we often get asked about what's the network impact and demand, especially it's a public cloud, so we're concerned about that. It's difficult to characterize by user because somebody doing rotoscoping is going to have a pretty low bandwidth profile compared to, say, a video playback, and there's a display resolution, the display topology. These are all factors that impact your overall network profile. But this graph here is a studio which was nearly 70 users, dual HD, a selection of use cases, so different types of texture and different types of artist functions. And we were looking at a little over 5 megabits per second on average. That's because the protocol for areas of a display that are not changing or static, or when somebody goes away from their desk, it's not communicating any data at all. So that's just an overview. We're out at the AWS booth. So later today, if you want to find out more, feel free to drop by and speak to one of us. And with that, I can pass it off to Mike. Thanks, Mike.
So what I want to kind of sort of go through now is the actual implementation and how this can actually be delivered and how you can essentially take this live essentially today. So when it actually, for us from the AWS and from the ThinkBox, kind of the VFX division kind of point of view, me based in London, we're very much talking to a lot of the customers, easy in Soho to see many customers in a short space of time. And there was this demand for both Linux and Windows for dual HD monitors, but as Ian kind of sort of explained, with the color and pixel accuracy, but also the video and audio synchronization, absolutely critical things. And also the sort of the problem with the resource levels in terms of actually the availability to actually buy some of certain Wacom model types were actually diminishing in the market. So a lot of companies were actually buying the latest Wacom tablets, which may or may not actually work as well. So there's kind of sort of a few things that all wanted to come together to provide this instead of CapEx and OpEx kind of experience of being able to have these on-demand machines. So very much the burst compute story has been told an awful lot, but conceptually the idea of very fast pop-up studios, the idea of burst artists, and of course the idea of streaming pixels, it can all be safe. You actually then completely potentially circumnavigate the idea of having to do this data synchronization between your one or more on-premise locations, having pipe and the link fast enough and a transport protocol to be able to transfer gigs, terabytes, whatever of data. If potentially these workstations are in a cloud as well, then could your storage be in the cloud as well? And that would be the same place as perhaps your computers as well. So it's maneuvering around effectively this problem that we have. I guess it's kind of, that's quite an Englishman's thing to say, isn't it? Beats Brexit. We have a fantastic way to self-harm. But it's the same in our industry, whether you call it that or you call it tax credits or you talk about the dynamic manoeuvring and changing of our industry and the ability to actually, how can you actually lower that business risk? How can you actually be more dynamic to actually meet not just the credits but also make yourself safer in terms of your business? In London, power is very much a problem. There's other cities around the world that regularly get brownouts or blackouts. That is a real problem when I've got a delivery to a major client and my project ends tomorrow, and I get some serious power problems and I can't run all my render farm or my storage goes down, for example. The promise of the cloud should be and is, from our perspective, the ability to actually iterate faster the specification of the EC2, that's our compute instances, and be able to deliver you faster iterations with the latest hardware at potentially a faster refresh rate than you can achieve on-premise. So perhaps you extend those warranties of those machines from 3 to 5 years to get the most amount of money and performance out of those machines. But actually, in reality, maybe at 4 years and 5 years, those machines aren't really delivered to your high-end grading, finishing 3D artists, but actually are probably used for sort of the junior, the modelers, the lower-end kind of activities, which don't strain it as much. Where perhaps if these machines were running in the cloud, they could actually be iterated on and you could have a new instance type with a new specification in a much shorter period of time. And the idea as well of perhaps actually multi-site and global pipelines and being able to actually bring everything together. So I'll talk about the blog post later, but really I just wanted to kind of sort of dive into how does this actually look in reality to your environment and your studio. So you can kind of sort of draw a vertical line down the middle, and we'll just sort of talk about Windows on the left and Linux on the right. So critical kind of components aren't just the keyboard and mouse, are of course used in different Wacom tablets. The latest ones, for example, the 660, 860 and stuff like that, but also the Cintiq tablets for Photoshop, Digimat painting and stuff like that. But the idea that they can, of course, communicate over the public internet, I'd suggest VPN for security. But the idea of using that low latency, which is what you're really going to get delivered by having a dedicated fiber link, remove the attack vector of not traversing the public internet. That's what a direct connect or fast lane connection is. That allows that fiber connectivity into our fabric. And then you go as fast as our fabric can possibly cover, but essentially very fast. Allowing you to communicate to your one or more remote workstations, which is called a G3. That's a different generation and instance type. So we have a letter and a number. So G for graphics, freaks, it's the third generation. So at some point there'll be a G4. And the cloud access software is running on this machine together with the NVIDIA drivers, running on Tesla M60. And you actually have a CUDA-based workstation that works just as well or better as on-premise. So whether it's a custom machine image, we call them an OMI, an Amazon Machine Image, AMI, but essentially that's your virtual machine image, and that's essentially running all of your software. That might just then have some attached extra block storage, which is SSD based, to provide you lots and lots of throughput, and also the capacity for caching of local data, and also to run all your software. You can run multiple Amazon Machine images. Perhaps one image just has Photoshop and Windows on it, and a few other things, and another image has got all of your 3D and 2D software on it. On the Linux side, you might actually want to potentially take a kind of more of a Linux sort of VFX classic film pipeline approach, or actually you're using perhaps one of our other instance types, which is called an i3, which is our sort of NVMe high performance storage node, and that could be running as a cluster, and that could actually deliver all your centrally mounted and managed software. So your actual Linux Amazon Machine Image OMI on the right there is a very bare bones image, boots very, very fast, and actually all the software is sim-linked, and it's actually pulled from an i3 cluster of instances, and it's super fast, really nice, because then all your software is centrally managed and it's easy to version it. It works really well with your pipeline tools. So these are all things that many people here I'm sure are well aware of, but I just wanted to show the kind of the schematics of how does that actually look from your on-premise at the bottom to the actual AWS region, which should be your, geographically be your closest one for low latency reasons. So latency is super important. Sort of the 20 to 25 milliseconds being underneath that is really important if you're using the CAS 2.12. What's really great to see is Teradici is continuing to improve, locally terminate the Wacom drivers actually inside of the silicon in their Zero client. So what that actually means is the same way in which the keyboard and mouse has always worked very, very well on a Zero client, for example, with Teradici, now the Wacom works super, super well. Essentially, one of my tests that I always do is run up Nuke, bring up a 4K sequence, take the Wacom tablet, make a roto paint, a roto draw node in Nuke, and then actually use the Wacom pen to actually make a kind of a spline. And you'll actually notice previously there was a little bit of a lag. Even with really, really fast connectivity, you could still see a little bit of a lag, and that lag is now gone. So it literally is as good as running that machine on premise. The speed of light, I can't fix that one. That will always apply, so use the closest AWS region. If you're blessed with geographically being a little bit closer in Europe, you can actually mix things up a little bit. I'm based in London, you could use the London region, you could go over to Dublin, I can go down to Frankfurt, I can actually get to Paris, and I'm pretty sure I'll be able to get to Sweden as well once that region is open as well. So in terms of examples, to kind of let's put our feet on the ground for a second and actually make this into reality. So in terms of, say, VFX kind of hubs, cities based around the world, let's look at the closest AWS region. Let's look at the fact that as long as it's relatively low latency, I'm not crazy, I'm trying to talk to a machine that's in Australia right now, we can actually seriously deliver this performance of a virtual workstation from these regions to these cities today. So you can see there the highest one is actually LA to go up to Portland. You can see why it's important to potentially look at a fibre connection, which is always going to be quicker, less noise, it's more secure, low latency. It totally makes sense. You can connect over the public internet as well. And these figures are always going to be based on your last mile as well, which unfortunately, from my point of view, is out of your hands. So connectivity, where you choose your office and your offices for your studios in the future, really is actually going to be super critical when it comes to, what are my network providers to this office? What does the fibre actually look like coming into this building? It's probably going to be some of the most important questions. So you should definitely work with people like Sohonet to see what the kind of connectivity you can achieve. But potentially with these kind of figures, as I said, you can, even with say LA all the way up to Portland or Oregon, you can actually quite easily control these virtual workstations. So in terms of the instance type, to make it specific for AWS and what we're talking about here, the G3 that I explained, we don't need to use the medium or the really high spec machine here. We're just going to use the bottom spec machine. 16 vCPUs, that comes with 122 gig of RAM. It has one GPU. There's absolutely no point in purely for monitor streaming purposes, having more than one GPU. It's more than adequate to stream dual monitors in the setup that I showed in the schematic. If you want to add more GPU cards with the higher instance types here because you're using a CUDA renderer like Redshift or Octane, that's completely possible as well, and that's doable as well. And I'll show you a trick in a moment about GPU rendering as well. But when we look at just the workstations here, the spec is really, really good. It's going to continue to iterate because of the promise of the cloud, as I said, and it can support the resolutions and the monitors and everything that you need. And it's kind of fantastic to see some of the customers I saw in London one Houdini artist doing an awful lot of simulation on this machine, had a 3-year-old machine, 64 gig of RAM, and he literally was just like, don't take this machine away from me. My simulations are so fast. This is really, really helping. So they've been a really, really good experience from the people that I've been working with. So if we narrow this down, and let's just look at pricing, for example. Linux is always going to be cheaper because you haven't got the Windows operating system pass-through costs there. But both platforms are fully supported here. There's no difference at all. So just looking at the examples here of Portland or North Virginia, costs here, what we're essentially looking at is the idea that this pricing moving from I've bought this machine, I will run it, and that's just a fixed cost when you bought that machine for 3 years or maybe 5 years. We're talking about an operational expenditure here where we're actually going to turn these machines off. We're only going to run them for, say, let's call it for this calculation, so I think it's fair, 10 hours a day, 5 days a week. We're going to not even take into account the fact that most people will have a few weeks, maybe a month if you're lucky, of summer vacation or whatever vacation throughout the year. So there's like 4 weeks maybe or 2 weeks where the machines are completely going to be off. So that's potentially up to a month there where there's no cost at all out of the 12 months of the year. So the cost there has to also include the cloud access software, which has essentially 2 options of sort of the cents per hour at 50, or just an all-in, the 240, which includes the cloud access manager, which is the brokering system that Ian spoke about. And the other thing, when it comes to ingress, that's free, but egress, so the data as it's streaming, it's just 2 cents per gigabyte, and that's actually discounted compared to if you were doing it over the public internet, which is another good bonus for having it over the fibre interconnect, as well as the speed and latency low levels. So what we did was we sat down and we looked at how easily can we actually build out an Amazon machine image, how can we make this stuff really, really deployable and easy to actually do for people. So the great thing is, as a byproduct, is we only had to use the lowest spec machine we have, so that obviously the lowest cost there. It just happened to be the right libraries for GCC and LDD for libc in terms of the VFX platform, not the one in draft, but 2018. So it's actually compliant from that point of view on those libraries. Just use the base CentOS 7.4 image, but it can go as low as 7.2. Always use the latest NVIDIA grid driver that's available from AWS. It's in an S3 bucket. One command, it just downloads it. It's super easy. And that then gives you essentially the latest NVIDIA drivers. The grid licensing is what allows you to have multiple monitors that can run up to 4K resolution per monitor. Now, the CAS software from Teradici is already up to 2.13 since this slide was wrote, but I like to keep these old versions just to show that essentially all these numbers are already out of print. You just need to grab the latest versions, and it's all working really, really well. An interesting kind of situation, if you're a Nuke or a Mara user, was the Pressure sensitivity from the Wacom tablets from the newer generation went from 2K to 8K levels of pressure sensitivity. And so there's kind of like a bit of a problem at the moment. I'm sure that the Foundry guys, we're in close contact with those guys, but they're fully aware of this problem, that the pressure sensitivity just needs to be locked. And if you take on the Linux side of things, there's the Wacom driver can just be configured with an environment variable, which is literally pressure 2K equals true, and that just locks the pressure sensitivity of the Wacom down from the new 8,000 levels back down to the 2,000 levels. And you'll notice that straight away, because Nuke and Mari won't have it won't be able to understand the different levels of the pressure sensitivity without that fix in place. But just combined, that environment variable, simple as that, those things in place, we can essentially can deploy an entire workstation. So down on our booth on the exhibition show floor, we've got a live workstation, we've got a Windows, and we've got a Linux workstation with the Wacom tablet, keyboard, mouse, all hooked up. And it's over the public internet here because we can't get a fiber connection for the few days of this show. So you're actually hitting about 20 milliseconds over the public internet at the moment. And both of those machines are working really, really nicely, 2K, and we're running all the software that you would expect on those machines. And you're more than welcome to come and test those and see how that works for you. So I mentioned another way for GPU rendering, and it's about the instance types and why AWS has all these different instance types. It's about finding the right fit and what's right fit for purpose here. So I just want to mention the P3 instance type here as well, which goes hand in hand with the G3. And it turns out that the P3 for accelerated compute, for machine learning, AI processes, very high specification Volta cards. And it turns out that as you actually increase the size of the instances, and I put the CUDA cores on the right there, what you can actually see is where we use the G3 4XL, which has got 2,000 odd CUDA cores, you can see the SKU very quickly, P3, even the base spec is over 5,000 CUDA cores. And so what's interesting, you can take things like the Redshift GPU benchmarking scene files, and a G3 render in Maya that I have there takes about 9-10 minutes, and you put it on the P3 that's got just under 41,000 CUDA cores, and it takes 19 seconds. So having the ability to use the right instance type to actually then process the information, whether it's GPU rendering or we've got lots of very large, very powerful CPU based machines, can actually go hand in hand as part of your render farm, as well as the interactive machines as well. So there's two much easier ways to essentially deliver the virtual workstations to you today. The AWS Marketplace, that's the URL, already has those pre-built Amazon machine images with the NVIDIA software and the cloud access software, one for CentOS, one for Windows, and you can literally just use the search bar at the top there to search for those machines. And then you literally hit subscribe into the region of your choice, and it will start up that machine, and there you have the virtual desktop. You can connect to it, takes a few minutes, and that machine is then ready to go. It's in your account, it's under your control, it's your machine, and you can run up as many of those as you want, and then just install your software, and it's ready to go. So in terms of making this actually real as a proposition, in terms of studios that actually would like to test this and everything we've shown today, we're more than happy from our perspective, in partnership with our partners Teradici and Sohonet, to actually provide proof of concept, and that comes in the form of usage credits from our point of view for EC2, cloud access software in terms of trial licenses there. Sohonet will do a customer trial of Fastlane for you. We also have an agreement, this is just specific to AWS, we have an agreement currently with Autodesk in terms of evaluation of their GUI, and that's, I want to re-emphasize that, not their render node licenses, but their GUI licenses of any Autodesk software can actually run in this environment as a proof of concept as well. So from a licensing point of view, you're good to go as well. And of course, we're going to provide you with the support if you'd like to test this as well. So just to finish off, I mentioned the marketplace, and I think that's a fantastic and really super easy way to just click to subscribe and start that Amazon machine image. But if you really want the absolute, every single bit of detail that essentially I've just gone through and summarizes everything that's been presented in this session today, is that shortened URL is essentially the key to absolutely everything. So what I wrote is a blog post that's on the AWS Compute feed. and it essentially summarizes and shows in very deep detail how to literally build your own virtual workstation, one for Windows, one for Linux, showing you every single shell command. Some of it who are very Linux savvy or Windows savvy administrators and engineers are not going to need perhaps this level of commands, but if you have you're a freelancer or you don't have any IT staff in your studio, literally this blog post tells you absolutely everything you need to know, and also includes the links to those marketplace OMIs as well. So it should be a very, very easy way for you to get ramped up with the correct IDs to literally start those up in the region of your choice. We're also looking for feedback as well. So the G3, the P3 instance types that we run are available in many, many AWS regions, but not every single one. So I'm looking for feedback with regard where you'd like to see these things, like where you're based, your studios, and perhaps what's most important for you. So we've got about, this has gone very well to plan, we've got about 10, 15 minutes. And I thought it'd be good to invite Ken and Ian up to really just tackle any questions that you may have about this entire workflow.
It's hard to see when you're up there, but question here.
I can't see anything, it's just these two blind.
Two lights. Come stand here.
It's the annoying guy from Wacom. 4K.
Yes.
So the new pen displays. Thank you. In case you can't hear me, the new pen displays, the Cintiq Pros, are all 4K capable. I noticed you were mentioning 2K. I'm assuming 4K is not a problem at all.
So it all comes down to really the streaming protocol, being able to support the 4K. And so the Teradici guys are really working on that at the moment.
Yeah.
Excellent. No, so have you guys been playing with the new Wacom products?
The new
Cintiq Pro?
Cintiq, like the model Cintiq
Cintiq
model?
Pro 24 and 32.
The 22, the 24.
The 22 and 24, I've directly worked with a couple of studios and they are working.
Okay.
But I think you've got some even
But
newer ones.
Brand spanking new ones. And
I don't know what the numbers are of them, but
I will swing by and make sure that
If
this
the
is all resolved.
But
The
we
22 and
do
24
work with the
are good.
Wacom team directly as well. So.
Perfect.
Yeah, and historically we didn't, and so that was why, many years ago we were always reverse engineering, and we've got well synchronized now. So.
And that partnership is fantastic. So like on the driver sets, if things change on the Wacom side and stuff like that, you're going to absorb that stuff. So it really there's good parity there going forward. I think it's a really good sort of partnership because there's so many people, so many artists that do actually use the tablets, all the Cintiq.
Thank you.
So
Let me help.
cool.
I'm curious how you deal with the software licenses. Obviously, you mentioned
Yep.
Autodesk, but
Yep.
for Adobe, Photoshop, all those other things that people use a lot of.
Yep, sure. So it's an evolving space. There is no one answer. I'm not going to, there's no smoke and mirrors here. So this is why we knew it was critical to partner with Autodesk, which is such a fantastic partner for us because from an AWS perspective, so much of Autodesk obviously runs as an enterprise level, one of our big customers in AWS. So the partnership was already there, So being able to say to them, look, we really think that this is a viable option for burst artists, especially for like studios that need to quickly ramp up and not invest in a lot of workstations, and quickly get freelancers and artists in, and that talent could be anywhere around the world. But how do we handle the licensing? So Autodesk were very, very keen to help us on this. So that's fantastic. So that's fine. When it comes to all the other products, it's literally on a case-by-case basis. It's evolving to the point of which I think there will be announcements over the forthcoming months and stuff like that. And definitely, as we go towards next year as well, with regard what are all the major DCC applications doing? Are they delivering, licensing that does allow you to run on a machine that's virtual or a machine that's virtual and you don't own, i.e. like a public cloud machine image? But it's an evolving space. And there is money, there's revenue here to be had. I'd be very shocked to think that these software vendors would not want to embrace this. We've had clear direction from Autodesk that they do see this as a fantastic opportunity, and it's as I said, it's evolving.
Fair enough.
Yeah.
My question's mostly for Ian. I'm right here. You can't see me at all.
Now I can.
You mentioned a little bit about the average bandwidth that you would see for artists, but then you, of course, mentioned all the different variables in effect. Do you guys see like really large deviations in that kind of
Yes.
bandwidth. Okay.
Yes,
Yeah.
on a per user basis, you need to configure every user with, say, a floor so that at least they get that minimum amount.
Mhm.
And then the protocol is pretty intelligent as to how it needs to burst. So it will, if the network's fully consumed, it'll drop a frame or dial back quality and do a combination of those in the dynamic state. But if you're doing full frame video playback at 60 frames per second, you're well over 100 megabits per second during that time. But it'll fall down to 0. So the best thing is to characterize, because the combination of users are all they're sharing the bandwidth effectively, and so they don't compete with each other in terms of individual users, as long as everybody gets a floor.
Is there a given VFX discipline that you see is the most challenging when it comes to that bandwidth?
Well, in the 60 people are working in the 60 frame per second, and then the full screen playback, so video editorial and broadcast is, well, VFX, sorry. Broadcast is probably the most difficult because they cannot lose a single frame in that playback because they don't know if it's the source or the playback. So VFX, often you're replaying it, so you might get an occasional drop, but you won't get it as a repeated thing. So basically it's the number of pixels that are changing. So if you have a full screen changing, then you're going to be driving up bandwidth. And you're also driving up the demand on the encoder. So if you have two full screen, if you've got a dual display system and both displays are fully changing, which is not the usual use case, that'll be your most demanding. Then single display changing, typically the other display is doing some menuing stuff. And our protocol is intelligent in determining not to poll the display that's not changing all the time, because we don't want to drive the CPU unnecessarily. So we intelligently look for the change and then put those resources on the encoding of those pixels. But as you make display windows smaller, so it drops, and once you're down to a small window, you're a sub a megabit per second. Right?
Okay, thank you.
You guys offer, if I remember right, 2 different ways of getting to the internet. The Teradici, I mean, you've got the thin client, and then you've got the software that'll run on a workstation that will allow you to connect to another workstation in the cloud. Am I right about that?
Yeah. So I didn't spend much time talking about the endpoint technologies, or the zero client, which is the encoder, silicon encoder. Then we have a software flavor which could be run on Windows, and Linux is in preview for that, which could be run on a client of various types. So it could be just a PC client or a workstation client. And then we also have mobile clients for iPads and things like that.
Okay, I didn't know about that one.
Yeah.
So I was curious about some of the specifications that you worked out. Were those intended on thin clients, or are those intended for, are you seeing differences between those?
Yeah, so
what's kind of a minimum machine you can run it on?
Perhaps are you asking, like, does the capability of the client affect the user experience? Right, so the client processor capability is important. And that's why our zero clients, which have dedicated hardware decoder, are the highest performing solution. So if you go to a laptop 5 years ago, the performance, there was a big delta, but with the CPU technology moving along, a laptop will give you now about 80% of the performance of a zero client. Still not there yet, but it's nearly there. It will, within 2 years, it'll probably surpass it. And thin clients have a very broad spectrum of CPUs, from very lightweight things that can do 2 frames per second to pretty hefty things that cost $1,000. So there's a spectrum of thin clients. And the memory bandwidth, there's a bunch of factors on those clients: the memory bandwidth, the display resolution. Those are all going to impact the overall experience.
Yeah. Don't forget that with the zero client, essentially you don't have an operating system that you have to have an administrator to patch security, and look after that OS. With a thin client, you are running an operating system, whether that be, say, Windows or Linux. So it's kind of open at the moment in terms of choices there. We focused on the zero client in this presentation, primarily because there is an awful lot of your devices out there, and an awful lot of them are in our vertical. So it's essentially a sort of tried and tested technology. We know we've got the networking capabilities to actually achieve this. And it's essentially, from the user's point of view, it's a change of an IP address to now go to somewhere else where your workstation is, as opposed to on-prem.
I don't know that I'll need it. How are you guys managing color management, for instance? Is that incorporated?
So from the Teradici point of view, we are taking the pixels that are rendered by the graphics system and transferring them across to the client display. So if there's a calibration of the display, that's independent of our protocol. We're not messing with the color in our processing. In the dynamic state, you may get color changes because we're doing some compression, but as soon as the image stabilizes, you end up with a bit exact replication of what was intended. So there's still color management required for the display, and you need to collect a colorimeter to a USB port and back to your host site. But we're not messing with the.
It's no different from how you do it on premise.
Yeah.
In terms of color calibration of your monitors,
Yeah.
ensuring that that it's done on a regular basis. Yeah.
That's awesome.
Yeah.
So I had a question regarding last mile. You said it can be an issue. With telecom operators now moving towards an SDN style deployment, is that becoming easier to be able to burst across that last mile?
Well,
Is that
I don't know. Pat's our lead network engineer, so I can actually pass. Or actually, if you want to, why don't you grab the mic and then you can. By the time I got enough, it would be unseen.
Yeah, so I guess do I need to go behind the speakers?
Come on,
He wants you on camera.
everyone come
He
up.
wants you on
Everyone
camera,
come
so you're in
up.
the video. Pat Sumby, everyone.
So I think the question was SDN, SD-WAN, last mile bursts, things like that. So yeah, I guess there's still physical infrastructure that needs to be deployed. So you can run an SD-WAN solution over a DSL line, but you've still got a DSL line. So don't expect some magic web page that you can log into and suddenly you've got more bandwidth from your ISP. So you need a network there that's scalable. Obviously the services we offer are scalable up and down. A lot of telcos will tie you in for a long period of time on that sort of bandwidth. I think where SD-WAN, whatever that ends up being, because depending on whether you search one website or another, it means different things to different people. So you can optimize connectivity over the internet using some SD-WAN techniques, but it's not going to give you more pipe into your building, I think. Does that answer the question?
Yeah.
Cool.
Cool. Thank you, Patrick. I think that's probably about time. Before we're not late for the next one. The main thing is, if you'd like to actually see this stuff for real, as opposed to us just talking about it, we're on the exhibition floor, on the AWS stand, there's a pod there, and on the booth, as I said, we've got both Windows and Linux workstations. Thank you very much.
Thank you.
Thanks, everyone.